was sad, and I have to say it's the end of my semester. I confess, not too sad. But in any case, for those of you who came today, I wanted to thank you for coming throughout the semester, both in person and those online. It's been a pleasure to have you, particularly as we are finishing the COVID period. So it's been challenging over the last 2 years, and challenging this year again. So thanks for sticking with us throughout the year. And today it's my great pleasure to reintroduce Aydin Mohseni, who most of you know because it's not the first time he's giving the talk, and he's been with us for now a year. Aydin got his PhD from Irvine in the Department of Logic and Philosophy of Science in 2021, so very recently, with Simon Uteger and Kevin O'Connor. And since then, he's been a postdoctoral fellow at the Center for Philosophy of Science with us. It's been a wonderful year to have him around. It's actually quite a delight. But it's also not his first time in Pittsburgh, because he spent actually 2 years at Carnegie Mellon University for doing his PhD at Irvine. It's published widely in philosophy of science, the formal epistemology of science, social epistemology, and philosophy of statistics in all the best journals, the GPS, philosophy of science, synthesis, and so on and so forth. And it has interest in how social epistemology relates to issues in science, in particular the replication crisis. And we'll hear about that today. Floor is yours.
Thank you for the generous introduction, as always, Edward. And thank you all for being here on a lovely, lazy Tuesday afternoon with reasonable Pittsburgh weather at the end of the year. Yeah, so today I'll be talking about a project in modeling interventions in the replication crisis.
Interventions on the Zoom screen, not so.
That's right. That's right. Those are challenging. Also non-trivial. So for this audience, the replication crisis in the social and biomedical sciences needs no introduction. Suffice it to say that from my perspective, the most productive way to think about the issues that we confront in the replication crisis is to see them as an opportunity to reimagine and move toward a healthier, more reliable, more productive future science. That said, much of the dialectic regarding the crisis has involved a kind of problem diagnosis model, right, in which folks have observed long-standing challenges and issues in methods and incentives, ranging from p-hacking to fraud, and proposed, right, reforms that I'm calling interventions meant to address these problems, from redefining statistical significance to doing away entirely with the framework of null hypothesis significance testing. So given the space, right, of identified problems, all of whose relative contributions we don't still fully understand, right, or we understand to varying degrees, and a host of interventions, the one we can consider individually or in tandem, right? The project I'll be introducing you to is meant to help us model, right, to augment our reasoning about how to move forward toward that better state of science. And I'll be doing it by introducing you first to what I'm calling the filtering model of science, right? A particular way to think about the features involved along the production pipeline of scientific activity. Now, this is not meant to encompass everything, but this is meant to be one model that helps our reasoning, right, about the effects of, and organizes our thinking about the effects of those interventions. And I'll be introducing with you to some open source tools I've been developing as part of the open science framework for modeling these interventions, right? For beginning to make explicit our reasoning and to share broadly with one another. Importantly, right, as with, I'll be giving you a kind of number of caveats along the way. As with all models, this is meant to augment our understanding in tandem with much other work, empirical feedback, kind of ongoing conversation. But if I'm successful, right, I should leave you thinking that this is a worthwhile project. Right. So that's the broader aim of the talk. At an object level, to show you that this framework is potentially worthwhile, I'm going to illustrate a particular effect I'm calling soundness-dependent filtration. And this soundness-dependent filtration is the observation that interventions can differentially affect studies as a function of their methodological soundness, which is something we'll cash out more precisely. And an implication of this observation is that interventions can look good at the level of individual studies, right, may actually end up badly when deployed at the level of a community or a population of studies. That's one reason why we want to be concerned about it. And of course, this is going to echo a kind of moral that we should be alert to coming out of the social epistemology literature, which is the methods that are optimal for an inquirer and those that are optimal for community might not be the same. And we're going to use this framework to think about, right, one such way that might be. Now, this soundness-dependent filtration can produce a reversal, right, in the reliability of a population of studies, right, under the following conditions. When there's variation in the statistical properties of the studies, when there's variation in how the studies are affected by the intervention, right? They're not all affected equally. And when the literature that's produced at the other end is affected by publication bias. And for those of you where some of these terms, like publication bias, right, are unfamiliar, we'll be spelling everything out. Now, importantly, my aim is not, emphatically not, to argue against the interventions we're going to consider here. Right? Judiciously employed, each of these has its place, by my assessment. Right. And this framework can help us think about what that is. Right? So let's introduce this filtering model. Consider a unit mass of statistically independent studies, right, where a study consists of a hypothesis test between a pair of null and alternative hypotheses. And let theta denote the fraction of alternative hypotheses that are in fact true. I note this is an adaptation of a classic model of bias in science, first popularized by Unides in its 2005, why most published research findings are false, and adapted later by many, including Tufano and List. And to illustrate what I just described, you can imagine that in a particular discipline, right, in the social and biomedical sciences or subdiscipline, scientists characteristically bring to test a body of studies. These are the hypotheses they think to test, right, informed by background theory, informed by domain knowledge, interest, so on. Of those hypotheses, right, that they bring to test, some fraction of them are going to be true, given by theta, and some fraction are going to be false. They submit their hypotheses to test, right? And these tests exhibit well-known properties. So of those that are true, we can observe that, right, 1 minus beta, that is to say, a portion given by the power of the studies will be detected as true correctly, and a portion given by the false positive rate of the studies, alpha, will be filtered mistakenly as true. And this is going to result in the literature of findings that are claimed to be true under some approximation of the kind of Speech Act, which is to say something significant. Good. So this process lets us now think about quantities that we care about. The one that we just mentioned is the false discovery rate of findings, right, given by the fraction of these findings that are both significant, right, and false. So if we look at those things we said were significant, the fraction that are also false is going to give us the false discovery rate. And this quantity is of interest to us because, right, this false discovery rate is the underlying quantity for which the rate of replication is an estimator. So when we hear the Many-Lab study managed to replicate something like 60% of studies in a given domain, right? That 60% of findings managed to replicate is an estimator for this underlying quantity. Well, actually, it's the inverse. The 30% that failed to replicate is an estimator for the false discovery rate. So this is certainly not the only measure we care about. And there are others that we need to be alert to. And though much of the conversation has focused on rates of replication and thereby, right, on false discovery, we can care about false omission, right, rates, the rate at which we sort things into non-significant when in fact those were true. And we can care about magnitude exaggeration ratios, right? The rate at which significant findings tend to be exaggerated. And we can care about other notions that I'm happy to discuss in the Q&A, things like, that I've been working on, like decision relevant informativeness. So one looks, right, so take the perspective of like a Bayesian meta-analyst, someone who maybe needs to make a policy decision on, right, do we deploy vaccines or not, right? Do we invest in one social policy or another, or how do we distribute finite resources to invest in multiple social policies, right? Those are decisions that require us to have estimates under uncertainty, right? And that are going to be influenced not in a straightforward way by these, but that meta-analyst is going to care about the informativeness of science. They're going to care that at the end of the day, when she makes her decision, how good is that decision? What is the expected value of that decision? Right. So we can care about each of these in their turn. And we can notice now that we have our filtering model, what each of the interventions are doing and where along this process they're influencing the statistical properties of studies. Right. So lowering the significance threshold is straightforwardly going to affect, right, filtration at the intermediate level of tests by changing the alpha, right, the false positive rate of tests. Raising study power, well, will make the obvious change the filtration of tests at the level of power, right? Improving theory, kind of ambitious aim, will improve the base rate of studies that we submit to tests in the first place. And pre-registration, insofar as it prevents methodological bias, right, can improve each of these, and it might, for kind of more subtle reasons, even affect base rate. And things like publication bias are going to be here at the level of what does our literature look like at the filtration of journals, right? So this gives us a way to organize our thinking about the interventions, and in fact, to model these interventions, or try to. So one of the proposals that we can start with is this article from 2017 that had a few hundred prominent methodologists coming out and suggesting that we change the default p-value threshold of statistical significance from 0.05 to 0.005 in appropriate portions of the social sciences. Now, I think that this is something that actually changing the p-value threshold, we will have to do and we will want to do in just about every field. Unless we think that accidentally, right, the p-values that we've come upon by convention and history are precisely the right ones, we should think that we should, a more sophisticated, reflective, aware version of us would be able to modulate p-values given our interests by domain. So this was a big proposal, and there was an interesting dialectic of folks coming out and criticizing this as saying, this is a terrible idea, we'll not do this. And I think an excellent response and survey of the criticisms, right, is given by our own Edouard. And I agree with just about everything in this response, right? And there are folks who are saying, well, responding with, well, this isn't going to solve all our problems, I think. And a host of things that I think are actually well addressed in the original article. Or misinterpretations, right? But importantly, I think the framework that I'm introducing is going to take one of the criticisms, actually, from the kind of many different folks in there, and make it sharper. Make it sharper, not against the proposal, but rather, in a sense, I'm actually taking, in Edouard's response, he observed that the criticism that one of the people made cuts both ways. And I'm going to show us how it cuts both ways and look at what it means for thinking about what are the right significant thresholds. I don't think it'll always look like 0.005, right? But again, the folks who proposed this didn't think that this is surely the optimal one that we move to and we stick to forever, right? But the framework I'm proposing should help us think about what that should look like and how it should vary from domain to domain, right? Among many other things. So here again, we can look at precisely where in our filtering model, this intervention is supposed to act on the alpha of settings, right? The significant threshold, and thereby lower the fraction of false hypotheses that are mistakenly identified, right, as significant. Yeah, just so. And you can imagine it's going to have the effect that we desire. Before we had a higher alpha, so more false hypotheses became significant. If we lower alpha, the fraction of hypotheses that are significant and false is lower. So modeling this, our intervention is lowering the significance threshold. Our background problem is that there are questionable research practices producing differences in study soundness. And another background problem we have is publication bias. And the observation is that studies employing more questionable research practices can attain significance more effectively than those that do not. That might be intuitive to you, but we can spell that out. And this observation, this first one that I'm introducing to you, is not my own. The rest will be, right? It's not novel to me. This was presented in a paper by Crane in 2020, the impact of p-hacking on redefined statistical significance, and I actually think was done more clearly and better by Williams earlier, who presented a more general proof. So let's unpack some of our terms, get clear on the model. Questionable research practices produce methodological bias, such that more studies obtain positive results when the null hypothesis is true. And of course, there are natural reasons why the bias tends in one direction. And to think about what is the effect of this, we can look at the Simmons, Nelson, and Simonson article, False Positive Psychology from back when, in which with simple optional stopping, selective controlling for several covariates, they were able to attain a false positive rate of 60, an effective false positive rate of 61%, right, with their 0.05 threshold. So they're able to kind of explode that error rate through normal questionable research practices, wiggling the researcher degrees of freedom available to them. And as far as prevalence of the estimates of questionable research practices, lots of research has been done on this. And this John et al. Paper kind of can give us a sense of the prevalence of these. So failing to report dependent measures, right? Is at about 78%. Things like optional stopping, at some point about 72%. So the things that, right, Simmons et al. Were looking at are actually quite common. And they certainly were even more common just a minute ago. So let's spell out methodological soundness. A perfectly sound study is one that attains significance when the null hypothesis is true with a frequency corresponding to significance threshold. So it has exactly the error rate that the study describes. A less than perfectly sound study will attain significance when the null hypothesis is true with a frequency greater than that threshold by some factor, k greater than 1. And this is how we can model the end result of methodological bias. Good. And now we can reason in a kind of toy model to get the crane result. Thinking about the effect of lowering the significance threshold on studies when they're broken up into two types of studies, for simplicity. Imagine maximally unsound studies. These are studies that are going to attain significance regardless of the threshold. So you give me any threshold, and they'll give you significance. Importantly, this is an assumption that Crane requires for the result, It's the capacity for something like maximal unsoundness, studies that are totally unresponsive to the significance threshold. You can think of this as kind of fraud, is what it sounds like. Sound studies, in which, these are going to be perfectly sound studies that respond in the expected way to changes in the significance threshold, and their false discovery lowers in just a predicted way. Well, what happens as we lower the significance threshold under this kind of a scenario is that the sound studies contribute less and less and less and less, and the unsound studies contribute more and more and more in the relative proportion of the studies that are published. You can imagine the extreme case where you make the significance threshold, just for clarity, 0. Nothing should be published. The sound studies still publish, So you'll have a literature of 100% unsound studies because they said, P of 0, I'll give you that. Good. And here we illustrate just that. And I'm going to spell this out because we're going to see several more of these graphs. Here across the x-axis, we have the significance threshold set by convention. And we have the false discovery rate of this population of studies, composed of the sound and unsound studies. In between, what we see is the relative contribution, the relative fraction of publications that are unsound. In the beginning, they're half and half. As you lower the significance threshold further down, they become progressively more, the literature becomes composed of unsound studies. Good. So what that gave us was that if some fraction of studies is maximally unsound, perfectly flexible, meeting the significance threshold, then lowering the significance threshold will inevitably, ultimately increase the false discovery rate of a literature. But given that we might expect that there is some small fraction of fraud, but this is not going to be the kind of world that we expect to be in. And in fact, there are studies showing that in general, this notion of how much are people able to wiggle their degrees of freedom or willing to wiggle their degrees of freedom, we might call this kind of, that's called persistence, is limited. And people do it up to a range, and you imagine there's a distribution, That said, there are two things to observe about that. One is it will definitely make the actual result of lowering the significance threshold, whatever amount of fraud plus persistence there is, not this. It will not be the thing that we would think in the ideal case, where everyone is maximally sound and they respond to us in the best way. There will be a little bit of this. In reality, it'll be somewhere between these two lines. And that is something we should account for. Now, it doesn't give the Crane result, where Crane guarantees that you explode the false significance, the false discovery rate. But it is just the sort of effect that we should know. And the question of how much persistence is there, how much do people in fact wiggle their degrees of freedom, is an empirical question. And it's something that we can think of and measure and integrate into this sort of a model to reason about. And we might here's a prediction we should have too, is it's going to vary from field to field in folks' ability and willingness, right, to use their research or degrees of freedom. And what this would ultimately give us too, right, is again something that should be thought of rigorously as involving trade-offs. There will be some optimal point, because we don't want one. We always knew that we didn't want the significance threshold to be 0, we didn't want it to be 1, right? There's some point which is right for our field, and it's going to be given with trade-offs with those other error rates that we cared about, right? And you imagine that this is the sort of thing that you'd want a field to think about carefully and decide on its own terms. Right? Or with other stakeholders, you can think of kind of more public-facing or generally relevant fields. So clinical trials are a nice example of where we do quite a bit of thinking about what this should be. But often, I think, not sufficiently rigorously, not sufficiently precisely. Good. And this kind of a model will also tell us something like, imagine you start lowering the significance threshold for your field, and you notice the false discovery rate of published studies goes up. Right? That means that you overshot. It doesn't mean that you just shouldn't lower it at all. It just means maybe if that's the goal, is to hit them. If the goal, which I don't think it should be at the end of the day, is to hit the minimum false discovery rate, right? You might come back a bit. So this helps us to reason about the more complex reality that's going on when we spell out our assumptions. Good. Now we can think of another example, right, where we're lowering the significance threshold, right, and we're grappling with a specific questionable research practice, which is what I'm calling fallback harking. Right? And this is something that I spoke of early in the fall, so I won't spend much time on this point. But in fact, you will notice that it is one instantiation of this pattern, of this soundness-dependent filtering. So to spell out this effect briefly, imagine researchers follow this protocol of fallback harking, which means that what they do is they come to their test with some hypothesis which they think most plausible. They're like, this is the one I'm betting on, right? So this is why I'm doing the study. And they're to some degree informed. So the fact that they tested this hypothesis is actually evidence for the hypothesis itself. So this is a hypothesis better than random chance at being true, right? So they submit that to test, and if it's significant, right, they'll try to publish it. If it's not significant, they're like, right, too bad. Let me look at the rest of my data to find anything that I could locate that might be significant so I can get this article published. Right? They'll dredge their data. So if they act in that way, they start with the thing they believe, and then they act well if it gets significance. But they need to publish. So if it does not obtain significance, they turn to dredging the rest of their data for something that will let them publish. Then we'll get a very similar effect where lowering the significance threshold will apply pressure to these people in perhaps a way that you've already anticipated. Those plausible hypotheses will be less and less likely as I raise the evidential threshold to get significance, and folks will be forced to turn to their many other hypotheses that are possible in the data, right? And just because by count, by number of how many other things could have been, one of those can by accident attain significance. And then whatever happened to attain significance will be reported, but that was not the thing they chose, and therefore not as likely to be true. Right. Good. This was just a description of the two modes I gave. The ideal one that we will kind of say is the model for how scientists in such a context ought to act is they predict, they vet their hypothesis through the test, right? And they publish it, right? Harking involves looking at your data, right? After you've tested and seeing if anything turned out. You hypothesize after results are known. Characteristically, things that people predict are going to be more likely to be true than just anything that could possibly be a result. Right. And fallback harking involves doing this in the first case, and then doing this if you have to get published. And we get again, this sort of an effect where as I make it harder and harder for you to publish your main thing, you're more likely to dredge your auxiliary hypotheses. And therefore, the false discovery rate can lilt up. Now, again, what is the exact values of this and how strong will this effect be? Well, they're empirical questions you have to estimate. It depends on the prevalence of the fallback harking involved, like how often is that description true of scientists? What fraction of them, right? Those kinds of things that are worth investigating and finding out. Right? But when you reason it through, you recognize that that can well increase the false discovery rate for those researchers. And also, each of these is going to weigh in on our assessments of different interventions. So if we have a sufficiently good regime of registered reports, pre-registration generally, I think registered reports specifically, this is not an issue, right? We can obviate this, and this is reasoning through these problems also gives us like arguments in favor of these different interventions. And that particular intervention, I think registered reports, for a reason that we can talk about perhaps later, I think is one of the best. If researcher choice of hypotheses that is informed, meaning better than chance, and researchers are employing a reporting protocol like fallback harking, then lowering the significance threshold can increase the false discovery rate of the literature. Right. And everything I said about the first case holds of that one. This does not mean you don't change the significance threshold, hoping that the current one that we landed on by accident is the best one we could possibly arrive at. Now, we can think about pre-registration as an intervention, which I mentioned. This is pre-registration broadly is one of the interventions that I find most promising, and registered reports specifically, where journals agree to publication prior to observation of findings, I think produces a better alignment of incentives. I think Edward has reviewed some registered reports papers and can testify to the fact that even as a reviewer, it's getting you to ask the right questions, which it's not. How eye-catching was the finding, but how good is the question? How rigorous are your methods? Right. Okay. But pre-registration broadly doesn't require pre-commitment by journals, but it does require pre-specification of study design and analysis prior to conducting the study by the researcher. And we can consider the case of voluntary pre-registration under a regime of publication bias, with questionable research practices producing, again, differential studies and study soundness in studies. And what we notice is that voluntary pre-registration and study soundness can be entangled. Again, we're getting a soundness-dependent filtration, and we'll see how. So this is also going to bear on the question of why voluntary versus required pre-registration. So right now in the dialectic, we've often been promoting voluntary pre-registration. Tell folks to do it on their own. We're not going to require it, right? Some journals have required it. Most still do not, right? And the thought there is if you get enough people, it's a very reasonable line of thinking. If we get enough people doing it, we'll kind of move over to the new norm, right? But enforcing it is harder. It might produce more pushback and so on. I think currently pre-registration is sufficiently flexible. You can even anonymize it. You can hide your data. And if you have a particular kind of considerations for clientele or privacy or whatever in the appropriate ways, I think pre-registration right now is really flexible such that I think we could require it. But the voluntary version has led the forefront, and it's going to be a problem with the voluntary rather than the required version of pre-registration. So we can model in our same framework, how does pre-registration work? It takes a study that had some degree of unsoundness given by its K-factor, and it moves it back toward maximal soundness. It doesn't have to attain it, right? It just moves it between maximal from its current unsoundness toward perfect soundness. By constraining researcher degrees of freedom, and empirical studies on this have shown that it's not perfect. Pre-registration still leaves some researcher degrees of freedom, but it does make often a substantial difference. Good. Now, the filtration happens under the following assumption. Researchers who are on average more likely to pre-register their study are also more likely to already employ more sound methods. And you can imagine about why that might be so. That is to say that the researcher is the common cause, both of already having been used more sound methods, maybe they're more likely to engage in their own statistical education, more likely to work with statisticians, more likely to be more conscientious about method, and also more likely to pre-register. So they're the common cause of those two factors, creating the correlation between them. If that's right, and if there's any positive correlation between pre-existing soundness of the researcher's methods and their propensity to pre-register, then you get this sort of filtration. And here we can think of the fraction of across the x-axis, the fraction of studies that are pre-registered, right? From none now to most. This is the direction of the intervention, and you're getting more of them to go, right? And these are unsound studies, right? Given by the fact that they're not being pre-registered. And these are sound studies that are being pre-registered. So I'm thinking of a simple world. Those who are, again, just for illustration purposes, the result holds in the more general case. For illustration, those who are using sound studies are progressively pre-registering more and more frequently across the x-axis. Those who have unsound studies, in the second dotted line, don't tend to pre-register. And again, what you see is that the relative contribution of the unsound studies goes up, right? Because the unsound studies have their higher degrees of freedom. The sound studies, by submitting themselves to the higher evidential standard, by saying, yet again, I won't wiggle my research degrees of freedom, I'm going to do a better job, I'm going to pre-commit, I can't, and so on, are taking their hypotheses that are more likely to be true, right, and filtering them more rigorously. So we see the same sort of effect once again. And this is just a statement of that fact. And the conjectured mechanism that would do this is a researcher disposition toward each pre-registration and sound method. And this again can increase actually, but again, the increase is under extreme conditions. We're going to think of what we want to know. The point of the demonstration of the increase is that it can make a difference, and we should be alert to those differences. In reality, we'd find out what would be the magnitude of the difference through empirical testing. A second mechanism that produces the same thing is researcher confidence. Before we had researcher propensity towards sound methods. The other one is if researchers are told you can voluntarily pre-register, they might not be as likely to pre-register the hypotheses they're not confident about. But with the ones that they are confident, they're like, no, this one's true. I'm willing to pre-commit to it so that I can't change the measure. I can't wiggle my methods afterwards and so on, because I'm confident. So if that correlation holds, once again, you get the precise same effect. So if the prior odds of the hypothesis being true and the researcher's propensity to pre-register correlate at all, once again, you get this sort of filtration. And you could kind of break down the assumption into parts. Researchers who are more confident in the truth of the studies are on average more likely to pre-register the studies. And researchers' confidence in the truth of their studies is on average at all positively correlated with the truth of their hypotheses, which we hope. We hope that's true. Might not always be. But we have some good evidence to say at least researchers in assessing the replicability of other studies are sometimes remarkably good. Good. And just as before, we have the researchers engaged in with the confident hypotheses, filtering them more rigorously, which ones that are more likely to be true, and the hypotheses in which they're less confident, not pre-registering them, and you get the same effect. You get an increase in false discovery. This is a statement of the result. If pre-registration and prior odds are entangled, positively correlated, then voluntary pre-registration can increase the false discovery rate of the literature. What we've seen that I want to highlight actually is when you think carefully about those results, they're demonstrating a pattern that was always there before we considered any of the reforms that we're talking about right now. Researchers who chose to commit their hypotheses to higher standards, to be more rigorous, to be more careful, were less likely, to get significant findings. This was true for every decade that there were such studies. Right. And those that were less likely were more likely to make contributions to the literature. And so there's a sense in which, right, this pattern relates directly to these kinds of thinking about the natural selection of bad science, about the fact, this kind of inherent problem in methods when you have a regime of publication bias and when you have differentials in researcher soundness of studies. Right. As I mentioned, one thing is if we had all registered reports, this would not be an issue. We'd be out of the regime where this would be a problem. Right. At least certainly the magnitude that it is. I mentioned that, right, we focus on one element of outcome, which is false discovery rates. There are the others I mentioned that I've done work on. We care about the magnitude of, right, say in medical findings, how big is the difference? It makes a world of difference to us. We care about the average exaggeration of that. When we're making policy decisions, we care about the informative list of literature. When we're doing a moonshot cancer research where we don't want to miss a possibility, we care about false omission. We care about all these measures, and this framework allows us to reason about all of them. Right? And those are kind of a further discussion. What it should help us do, as I mentioned, is augment our reasoning about these things, not give us our final say. If we should never think that we've modeled something where we've finished understanding it. Right. All right. Now, and there are other morals that it says, things like encoding in the pre-registration case, studies by pre-registration and not, and having that really be a more emphasized marker of the credibility of the study. There's already kind of informally some of this, but this emphasizes how important that is. Just as much as it pushes toward more required pre-registration, and also adjusting our expectations, right, toward understanding these underlying complexities of the dynamics of reform. Good. At the object level, we have this insight. Interventions and evidentiary standards and research practices need not affect all studies equally. In fact, we don't expect they will. And whenever those interventions are not entirely uncorrelated with study soundness, we should expect the sorts of dynamics that we just saw to obtain, to some degree. Publication bias makes all this much worse. But we know tools that can begin to address some of these problems. And we should take these as further arguments in their favor. To reason about these, I mentioned that there's tools, right? One of the tools that I've been building and that's available in the Open Science Framework, right, allows you right now to interact with just these sorts of questions and look at things like the effect of interventions under different assumptions about the false positive rates, study power, effect sizes in a field, on things like false discovery, omission, magnitude, exaggeration ratio, and other measures. So I invite you all to participate. Thank you.
We're going to take a 2-minute break, and then we'll have plenty of time for questions. Hello, sir.
Do you know how to turn it off?
I wanted to, that was lovely.
Thank you.
I think you mean fields when you say studies. You talk about like the impact of something on studies.
Oh, I didn't mean fields. You're absolutely right.
Yeah.
That was just a total slip up of the word. Yeah.
And like in the beginning,
Right, yeah.
you used it too, and I was like, I think he means fields.
Yeah.
Yeah.
Because there is one thing. There are studies which are the things that are tested. They contain a null and alternative.
Exactly.
That's what I mean by study. Discipline, I mean the whole thing.
Yes.
Yes, or
Yes.
field.
Fields.
Yeah.
Yeah.
Like, oh no, I didn't realize that I misspoke there.
And I think when you say that someone makes contributions to literature, I think you mean publishes something.
That's right. That's exactly right.
Not necessarily make a contribution. You can publish all kinds of things.
Oh, that's nonsense. That's right. That's right.
Whatsoever.
That's right. I'm thinking of in the mathematical sense of it added
Yes.
something to the published literature. Yeah.
Yes, yeah. That's all.
Yeah, how did you read?
I have another question, but those are like the things to make it a
No,
little.
I didn't.
No,
I will.
No,
I
I
will.
still appreciate you looking out for me.
Sorry about that.
Only if it's helpful.
Of course.
Sorry, I wanted to mention that I have a question, but I need to have like 5 minutes. So that would
You can be the first one to ask a question.
Yeah,
if you
I
want.
just didn't want to do that I leave.
No worries at all. And also, feel free to email me if you'd like.
Okay, perfect.
All right. Got questions? Please raise your hand. Go for it. Since you have to leave very soon.
Okay, perfect. My question is, what is study soundness and whether an agent or like a scientist could ever assess the soundness of the study, and how can we make sure that it's positively correlated with any?
Yeah, great question. So study soundness, as I had it on one of the slides, is when a hypothesis is false, in this case, right? The unsoundness is measured by the ratio of increase of the frequency with which that study produces a significant result. So in the hypothetical case, imagine you give me your study, right? And your choice of your significant threshold, your false positive rate for the study is 0.05. Right? So if I gave you a false hypothesis to run through your study design, if you did it 20 times on average, you get one time where you got a false positive. The rest are correct, false negatives. I'm sorry, true negatives. But if I were to increase your study unsoundness by say a factor of 2, right? Then out of those 20 times, twice you would get a significant result that was a false positive. So this kind of effective false positive rate, or the kind of the rate of increase, is something that we can measure and do measure in studies. And you can do it on your own study by giving the same protocol for the study and running through things you know are false and seeing the frequency with which that design would detect it. And there are also inferential ways to kind of get at it for literature, but that's a very important question. We don't have perfect estimates of those things, but we can get at reasonable estimates to inform policy choices. And as a researcher, you can also kind of get an estimate of it for your own study designs.
Heather, go for it.
Okay, thank you so much, Aydin.
Thank you, Heather.
I was wondering why K, maybe K should sometimes be greater than 1. Maybe we should lower the significance threshold, especially given some of the other considerations. And I was wondering if having that possibility in there messes up the modeling, or whether or not you could make K
Less than 1.
bigger than 1.
If K is the unsoundness, it is already by stipulation greater than 1.
K is the thing you multiply by alpha.
That's right.
So I'm saying make alpha bigger.
So,
Like whether or not that like.
yes, sometimes, okay, so maybe I'll take your question and say, would we ever want to increase the significance threshold from the current value?
Yes, and in some fields it has been,
And I think that
right?
this kind of framework would say yes to that, dependent on, and then you have to specify further things.
That's right.
And it would fall right out of this way of thinking.
Okay, so you could do it with the model.
That's right. And in fact, the model would conclude that because the values that I do consider for alpha are all between 0 and 1. Like 1 is the goofy one where you say everything is true, right?
Well, yeah, I mean for alpha, that's why it was for K. We would like make alpha bigger.
So K there is the kind of measure of a given study design, its unsoundness. It's already greater than 1, and it's multiplying alpha to show that the effective false positive rate is greater than the kind of declared false positive rate.
Okay, then maybe I don't mean K. I just mean like making edge alpha bigger, like 0.1. Some fields have it at 0.1.
So agreed, and this framework
Not psychology.
yeah, accommodates that. And I think you're exactly right that as we reason it through, it will be a matter of field to field, figuring out not just by minimizing false discovery, but weighing those other factors of, are we doing exploratory research? Are we doing confirmatory research? Is it about medicine hitting the shelf, or is it about not missing out on some long shot, big outcome hypothesis? That's exactly right. So you're right on.
Aydin, go for it.
Cool. This is great. I wanted to ask us if you're like convinced on the details. I want to ask something about like how the framework works, big picture. We're actually trying to implement. So like, I imagine for all these cases, I was wondering, well, of course, there could be other correlations that are relevant too. Like, well, maybe the researchers who are, more likely to be registered, but they produce more studies because they got more funding, or they're better at guessing the truth. Or, and I was just wondering, like, I mean, we get these nice curves like this. Imagine the more parameters we add, the weirder and more sensitive the parameters the curves are going to get. How reasonable is it to hope that sort of once we make like we want like a full model of like some like area of social stuff, like priming studies, and we want like a full model of what their p-value should be. Like, how much are we going to get out of the model, or is it going to be like, well, tweak this one parameter by an epsilon and everything?
So this is a great question, and you're absolutely right that this is the challenge of how to put a number of these insights, of being aware that this variable makes some contribution. Like, but what this variable makes some contribution. Now, how do we put them together, and how do we grapple with the possibility of all the latent variables for which we have not accounted? Is a significant challenge. Now, the proposition that I think matters for me is the value proposition of, is doing this better than not doing it? So does that state produce an improvement? And I think you can rightly question that, which is what I heard in your question, which is, imagine we do put a bunch of these together in our best model of a field. Now we look at that model. Is it an improvement over the status quo? And the status quo, I want to point out, is just us as primates making gestures at what we think is better, right? We just say, I think that's better, and we might make a verbal argument, and that's where we're at. Now, my bet is that this won't be worse per se, right? But that's right, one failure mode could be, we could finish this, we could build our model, but when we do interventions guided by it versus our kind of informal reasoning, it doesn't make much of an improvement, because maybe the world is complicated and like it's just predictably not that tractable, right? And the best model we have just can't do it that well. So I think that's a real concern, and that might be the world we find ourselves in. I'm optimistic that it can make, I'm confident it can make an improvement over that. And I'm hopeful that it can make a sufficient improvement over that, that it makes it worthwhile for us as a part of a kind of more competent future science. Yeah, absolutely.
Mr. Chair, to actually follow up with that question, but I had a very similar question, but in a sense, looking at one of those things you mentioned, so you look at voluntary pre-registration, and you're quite right in all the effects you're noticing. It's really interesting. But of course, it's also the case that pre-registration is not simply voluntary; it's also an informal norm.
Mm-hmm.
So you're quite right that it does impact false discovery rates the way you describe it. But not every paper that gets to be published has the same impact, the same influence in the broader scientific community. Right. So people who are not pre-registered, their paper are scorned upon. They're less likely to look with greater skepticism. They're less likely to be cited. And that does bear on the interaction with the Smaldino type of consideration. Yeah. So that's one of the examples where as soon as you just make things a bit more complicated, it's just hard to know exactly what to say, and whether any of this model is really actionable or not. Which I think was partly what Kevin was really concerned with. Is should we really act on this kind of models given all the complications are just bracketed for the stability?
Yeah. So I think that's just right. And the norm you describe is one that I'm very in favor of, right? Norms of valuing pre-registration and anchoring the credibility that we give, we bestow on studies in part as a function of where they pre-register as much as any other part of their method. And it's right that, if you're thinking of the situation and you're like, okay, should we make it voluntary or not? There's this other element that's interacting with kind of researcher assessment of credibility and prestige that's kind of hard to model and to reason about. And I think looking at the model and then noticing, right, I can't, that there are limitations to it. I can't answer the kind of, but I can try to ask it more clear questions.
Yeah, it's just a pretty simple, but I quite agree with what you said.
That's right. That's right. So clear questions we might ask are yeah, that's a hard one to say how worthwhile it is, because imagine we had the norm where we just didn't even pay attention to non-pre-registered ones. We could get like a secondary kind of like a dark literature where people don't pre-register, but no one really pays attention. But they only happen in, like, you know, top science journals. Go, you know, and scour the dark literature for those impressive, unreliable results. But then you could say, well, you know, how valuable is it to enforce pre-registration for those versus not? And that comes as a kind of a value proposition that's hard to assess. So I think that's just right. That some of the statements about what matters are hard. At the end of the day, I think that hopefully this contributes, while it doesn't answer all of the questions, it can contribute to our clarity.
Yeah, so I was actually, my comment was on the question questioner who left about unsoundness. And first, I really enjoyed your talk, and it was a lot of really surprising and fascinating results. And I guess as far as unsoundness, I think you've given a good account for, you know, empirically how we can detect the effect of unsound studies. But I find myself wanting more of, I mean, the idea of an unsound study, I think in some sense is that it will give you a vacuously true, you know, in some sense it gives you a vacuous positive, you know, vacuous account. And I have this feeling that if you were to look at particular studies, and, you know, no one wants to have to do this, but that you could go in and diagnose, I see where they got a test that's not really a sound test, or criteria is unsound in some sense. So it's a logical matter. So to me, it's a logical matter. Where, you know, I do go in and say, here's this study. I see what is logically disconnected between the criterion applied and the result we're getting. For instance, you could say, like, at some level, this is a caricature, but, you know, if I am 5'2", then I am the king of England. You know, so clearly I am 5'2", and so I have a positive result. I am the king of England. You know, so it's just kind of a logical point where your criterion is being used as a test for something that it doesn't really test. So that I kind of want, if that makes sense at all, I guess what I'm hoping for is some way to look at the issue in terms of out the logical fallacy in the unsound studies.
That's great. You're absolutely right that measure of methodological unsoundness is a summary of many different underlying ways, right, for it to be produced, right? So, and it can help to kind of spell out, and we don't know all those ways. We can get the study unsoundness, a measure of it, without fully knowing what caused it. Characteristically, the things that we have diagnosed as some of the main causes are things like, imagine I'm studying whether broccoli cures cancer, right? And I run that hypothesis through, right? Or some kind of vitamin has some kind of effect, some kind of SSRIs, and so on. You set up your hypotheses. And the things that we think create that greater rate of false positives are things like selective inclusion and exclusion of outliers. Things like, if there are multiple measures I could take, I look at the ones that would not make my study significant, and there's 7 of them. I say, not that one, not that one, by accident, right? And subsetting the data arbitrarily and finding, like, is there a subset of the data for which there's a regularity that crosses the threshold? So there is a vocabulary of what we call questionable research practices that is not exhaustive, and that you're exactly right, looks very different, that ends up getting summarized that way. But you're right that the way a study is made unsound will actually affect, right, the kind of intervention we care about, and the kind of microdynamics of it, which is what I think the harking example gives one sense of that, right? There's a specific way that the procedure itself of fallback harking is going to create a different form of unsoundness that's going to respond differently to interventions than selective choice of measure.
Just small practical concern. I was thinking about this notion of pre-registration, and I wonder how it is related to the notion of peer review, which is also quite problematic when it comes to publication practice. And in many specific fields, it's a fiction actually. So perhaps this idea of pre-registration should be a call for a broader reform of our decision making. It's published.
Yeah. It's true that certainly the form of pre-registration that is registered reports is intimately tied to peer review, involves peer review, right? The registered report is one that you submit to peer review before you get your findings. And it's right that if we're in a field where that assessment did no good, registered reports would, in a sense, do no good. That said, at least in these fields, my sense of it is that it is better than the alternative, right? There are lottery proposals right now, right? But I think, especially if we think of concrete cases, like, let's think of clinical trials in each of their phases, right? We have set up standards that have to be met, some of which are out of the peer reviewer's hand, but they're doing the task of just enforcing, did you meet the appropriate level of stringency? Were the right parties involved in the testing? Were the right thresholds evidentially met? Was the right sample size, right? Were your methods sufficiently transparent, and so on, right? And then, so at least enforcing those constitute, I think, a clear contribution of peer review. Now, I think you're exactly right that there are cases where peer review, certainly the case that peer review is more questionable in some cases than in others. And it's certainly the case that we can improve it. And I'm very much on board with proposals for thinking about what a more competent form of peer review looks like.
Two things. So the first is, how do you said that the different domains can decide what their p-value will be somewhere between 0 and 1. I think that's a really good proposal. How will that work? How does that work?
So
And the second thing is, quickly, is pre-registering process connected to that, like in the sense that we, they say, okay, this is what I'm going to be doing, and this is my p-value, and so on. So, okay.
Yeah, great question. So setting different conventional significance threshold is already something that fields like particle physics and parts of genomics have done. So we have the 5 sigma standard in physics, and we have kind of appropriate rates modulated to the kind of massive multiple testing problems in things like genome-wide association studies, right? Where you just know when you're testing that many things, you might want to have a lower false discovery rate than what you're going to get at 0.05, right? They tend to be like 0.5, I think it's 7. It varies based on study type. And actually that is beginning to show a model of what this would look like, right? Is you say, given my field and my interests, right? And you can, like we said before, like it's very value-based. I'm going to feel differently about clinical trials, phase 3, than I'm going to feel about totally exploratory work. We set it as the norms. Now, what we want is kind of decision-making bodies that effectively do that. Particle physics is famously kind of coordinated as a field, but this suggests that we want more coordination, right, across different fields in grappling with the implicit value propositions about the sorts of error rates that we have as a field, but even I think breaking it up into subtypes, right? We might want, each field might want to break up and say, these are the studies that are meant to really assess whether this is going to fall into the canon of we're sure this is the right parts of our knowledge, versus this is going to fall into that we're vetting the big possibility space of the world and for hypotheses that future studies will test more rigorously. So I think you're just right, and I think that we have some models of that in particle physics and genomics, but it'll, I think, involve a level of coordination that we haven't had in many other parts of the social sciences.
Andreas, do you have a question? Thanks. So one takeaway I got is that what makes experimental fields rather different than non-experimental is that you don't simply have the results, as in what's written in the paper. You also have the soundness, which is not in the paper, or at least a significant part of it is not in the paper. And in many of the cases we were discussing, it seems as if a really important factor is whether or not the soundness was there, and if we could somehow infer that there was soundness. That would be great if we could just find out which researchers had sound research practices. Now, one problem with finding that out is blind reviewing. And I was wondering, there's many reasons why we have blind review in fields which only results matter, because what else could you require? The research shouldn't matter at all. But in these cases, it seems as if there must be some factors which correlate strongly with sound research practices. And it seems irrational not to be allowed to use those. On the other hand, there's a danger there, of course, because there's all other forms of biases that could enter by knowing the researcher, but still, it seems strange to completely preclude any information about the researcher in our assessment of results when it clearly is very important.
Yeah, good question. Yeah, so I think that's right, and I would be very in favor of that in particular cases, in the sense of, imagine the kind of Bayesian decision I was talking about, how much to invest in terms of our finite resources in different social policies or medical interventions. There, the goal is really just optimal prediction, full stop. And a lot can hang on in the balance. It could be lives, it could be all the resources that we have. And there you use every bit of information in your model predictively, right? You wouldn't leave any information on the ground. Right now, you're right. One piece of information you mentioned is just what was the laboratory that did that? Which lab did that? That's some information. And people do use that when that's made available. It's not clear to me how effective that is at present. Or that is to say, it's not clear to me how much the kind of known reputation, maybe I wouldn't be surprised that it has some content. I'm not sure how much it is. We would need a kind of, it would be great if we had the world where we had the estimates of these labs produce this standard, this lab produces that standard. Right now, we kind of do informal, like, I know them, I think they're pretty good, right? Kind of judgments. I know them, they're prestigious. And I think there is still a lot of information in the paper itself, when you read it, that is kind of soundness relevant. Like when you just look at the sample size, when you look at, did they pre-register? Did you look at how many measures were available for them to wiggle? Did they, like a lot of times when you're reading these studies, you can notice like that was a very unnatural measure that you picked, or that subset of that is kind of awkwardly, that's not the natural hypothesis I would have thought to predict, right? So there is other information in the lab. I think you're right. When it matters to do the best, we include all the information, and that would be one piece of information.
Thanks, Aydin. This is really fun. I had a question about the pre-registration graph. So I don't know if you can pull that one back.
Sure. Rather, yeah, could you help me out with that? Which, great. Which one is this?
Yeah, I think it was this.
Or the previous one?
One or the other, I guess.
Yeah.
With both of them, it was just kind of, there's a lot of different lines going on. So,
Yeah, that's right.
are the X and Y it's really the same for each line?
Yeah.
So what about relative contribution of unsound studies? Is the y-axis just?
It's the same value in the sense of its fractions.
Sure, same
Yeah.
value, but not the same unit.
That's right.
And so for just that one, but are all the others? I guess I think that's what threw me off, and then I didn't know what's happening with the rest of the graph.
Good question. That's bad hygiene on my part. That's right. The relative contribution is in fractions. The rest are in units, have their units being false discovery.
Could you then just?
Sure,
I think I missed
absolutely.
what you were saying, so try
So-
to make sense of the graph.
Just so. Unsound studies have a false discovery rate that is unperturbed by pre-registration because they are unpreregistered. Sound studies have their false discovery diminished by pre-registration, right? Because it constrains bias.
And this is diminished by the fraction of studies that are pre-registered. So we're only going up to the idea that half of them get pre-registered.
That's right.
Never do we have more than half of them registered? Is that arbitrary or is that?
That was arbitrarily picked for like split up the population into two parts, half one, half the other.
Thanks.
And I can have,
You get put up.
and I can send you the slides too.
Yeah,
Of
no,
course.
okay, then let me just
Yeah,
say,
yeah.
then, so what's the big takeaway from all these different lines?
So the takeaway is the opaque line,
Yeah.
which is the false discovery of the literature as a whole. The published findings increases.
Cool, thanks.
Hazel, you had a follow-up.
Yes, so what I really wanted to ask you is, you gave this wonderful talk, and the main measure you're looking at is the false discovery rate.
Yeah.
What happens when you look at the false discovery rate, the false emission rate, the magnitude, exaggeration, decision relevant importance? Do you find trade-offs among the goals, or do you find synergies depending on the interventions?
Both.
Okay, so that might be the most important thing for Kevin's question. Like when you've got the synergies among them, you're like, oh wait, like this helps all, like 3 of the 4 of them, or maybe
Yeah.
all of them. And this one, like, no, we're trading off, we're as we have less false discovery, we have more false emission. I don't know about that, right?
That's right.
So maybe we need to like map all of the things we care about and show how interventions play, up and down.
So-
Have you done that kind of playing?
That
around?
is what the tool I presented begins to do. This one right here. It allows you to reason about each false discovery, false emission, and magnitude exaggeration. And you'll notice that they do, in fact, do both the things. Sometimes for a given intervention, it'll help both. Sometimes it will help one hurt the other under different regimes. And so it is very much a calculus of trade-offs. And the last one, informativeness, is what I've actually most recently been doing a lot of work on. The one where, to the point that was made, you want to make a decision, you want to be predictably optimal, right? And you might be very uncertain. You're not even thinking anymore about, did I cross a significant threshold? You're just like, we've got so many funds, there's so many programs, we have to make our best guesses and our best investments to make as much contribution to lives saved or what have you. And that has its own dynamics that are different. But yeah, there are lots of trade-offs between them. And it becomes an interesting space that I think more and more, to be more competent means to grapple with all of those. And I think Dora and Kevin's question to be at 2 levels. His was, can we get a good model given the world is complicated? And yours is, even if we get a good model, our values involve trade-offs and imply trade-offs for these choices. Yeah.
And maybe synergies.
And sometimes synergies. That's just so.
Be optimistic.
Cool. Maybe just a small question about the arcing model. Was I right in saying that model is one where, their chosen hypothesis, they get a better than average base rate of truths, but like once they arc, then it's just, you can say. How sensitive is that to, so I suppose, and presumably what people would actually do is like, well, they have a ranking of how plausible the hypotheses are. Like they start at the top and then, okay, that didn't work, and then they check this next one, and then like, how, I don't actually remember the qualitative results, but did they change?
The qualitative results won't change, but that would improve the picture, right? If my protocol is like, let me do kind of plausibility sorted falling back, right? That would make the outcomes less unreliable. but still more than they would otherwise be if I wasn't doing that. That's right. And that is a plausible, at least a somewhat plausible description of what we might be sometimes doing.
But they also probably don't care about how flashy it is too.
That's right, and that would push the other direction, right? It's desire for the most impressive result would be the one that would have the lowest prior. Yeah, that's a great observation.
2 minutes for question, a couple of minutes. Then I'll take the last couple of minutes to ask a quick question about the trend models that you that you discuss. As you mentioned, so his result is conditional on persistence being independent of the value of alpha.
Yeah.
And that's quite an implausible assumption in the first place, as you know. Now, did you try to model, instead of having a flat line, to have, somehow an increasing line to change the value of the full discovery rate due to hacking? For example, if you have an exponential curve, which I think is a much more plausible curve than a flat line, how does that impact the results? So, or is that built in your model that we can change the?
This one, no, but I have played with it, and the answer is just right. I've limited it to having a maximum methodological unsoundness. Now, you're exactly right. You could think of the function of how it increase and bound that, what you get is one that will change the range for which it's favorable, which is it can look, going to 0.005 can look very good, but then the numbers will change based on exactly that. So you're right, and I think you point out in your response to that under some assumptions you can get that it still does quite a lot of good to move to 0.005 for the field with the right sort of properties.
Any further questions?
Okay, I have another question. Okay, so
You have 1 minute.
I have 1 minute. I want you to reflect on how philosophy works. Because one thing about philosophy is, we don't do statistical testing very often unless you're doing empirical research. We sort of publish, people publish all kinds of things. It's very hard to have null results in philosophy. Something comes out of almost anything. Is that good or bad for the field?
I love the prompt. I think I think that I appreciate it's a description of philosophy sometimes attributed to Russell as the sun from which the kind of the planets are expelled in nascent form. And given that description of it being really a place to begin inquiry rather than end it, I think we're allowed to have wildly exploratory studies, and that's okay.
All right, thank you. Reminder before we break apart on